Hello everyone. Hi. Good morning.
Good morning.
Do you have any questions before I start? I'm going to continue chapter 2 and last time we talked about two measures, measure of center, measure of variability, correct? No, we just talked about measure of center. So, what are those? Measure of center? Mean and median. Okay. So now you know how to calculate mean, how to calculate median. Today we want to talk about measures of variability. The other name for variability is a spread. Okay, and one of these measures, so I will start with quartiles. We will talk about Q1, we will talk about Q3, and then we will talk about the standard deviation, and we show it with S. Okay, so quartiles are not difficult. It is similar to median. So I will choose one example. The same one, quartile. This one. Do you remember this example? So now we are going to find quartiles for this example. To find quartile, as I said, quartiles are the midpoint, but what is midpoint exactly? So we will talk about the first quartile, we will talk about the third quartile. In this example, the first thing we did to find a median was to organize the data, okay? And then after you organize the data, either you use formula or just cross the first and last number to find the midpoint. So now, please, give me all the numbers, organized one. So I can write it down here. And then I will explain quartiles using the same kind of number.
51.
What is that?
51.
51.
53.
53.
54.
54.
55.
55.
57.
57.
58.
58.
59.
59.
63.
63.
64.
64.
65.
65.
76.
76.
77.
77.
78.
78.
79.
79. Okay, thank you. So, what was the midpoint? 60 what?
61.
61. It was between two numbers, correct?
59 and 63.
Between these two?
Yeah.
Yes. So I will write down median here because median was between these two, correct? 61, you said. So now, to find a quartile, use the data set before the median. Median was between these two numbers, correct? So number before median was 59, correct? Up to the minimum. We will use this data set. So, I will write down first data set on this is the right side, this is the left side, correct? On the left side of median. I'm going to write this again. 51, 53, 54, 55, 57, 58, 59. So now we have a new data set. Find the midpoint here. Should be easy for you, correct? Find the midpoint. What is that? So let me cross the first one, last one, last one, first one, last one. This remains, what we call this? The first quartile. That's it. So the first quartile is the midpoint of the observations on the left side of median. Correct? From minimum up to the observation exactly before median. That's it. We call this first quartile. Then, do you have any question? Now, the second data set is from the observation after median up to the maximum. On the right side of median. So 63, 64, 65, 76, 77, 78, 79. What we do here? Find the midpoint, correct? Find a midpoint for this data set. Cross this one, cross this one, cross this one, and this one, this one, and this one. Am I right?
Yes.
We call this third quartile. The third quartile is the midpoint of the data set on the right side of median. So what quartiles do? Quartiles divide the data set, the whole data set, to 4 exact parts. 4 exact parts. It means from the first data set minimum to here, we have 25% of all observations. Means 1/4 of observations. From here to the maximum, what percent? The same, 25% of observations. What median used to do? Median is a midpoint. I remember I had this example. I said 50% of exam scores are on the right side of median, 50% are on the left side of median. Right, left. So, median divides the data set to 2 exact parts. 50% right side, 50% left side. Now quartiles divide the data set to 4 exact parts. 25, 25, 25, 25. So, my question is that, before I explain more. I explained Q1, I explained Q3. What is Q2? What is that? Median. Exactly. Median is second quartile. This is another name, the other name for median, second quartile. So now you will understand if I say what percent of observations are from Q1 to median, you should tell me what percent? 25%, exactly. And then from median to Q3, what percent? 25%. So now do you see? We have 4 exact 25%. From minimum to Q1, we have 25% of data set. From Q1 to the median, 25% of observations. From median to Q3, 25. From Q3 to maximum, so 4 same part. 25, 25, 25, 25. Okay, so now, do you have any question about quartiles? Let me see it. Now, you already should know what is the minimum observation, what is the maximum observation, correct? So here in this data set, 51 is minimum, correct? And then 79 is the maximum, correct? Look at this data set. So the first one is not organized. To find the median or Q1, Q3, we should organize this from minimum to the maximum, okay? So from minimum to the maximum. Then they found the median in middle of these 2 observations, okay? So this is median 22.5. And then exactly before median 20 to 5, we have one data set and they found Q1 between 2 observations. Sometimes you can easily find this. Why? Because probably the number of data was odd, correct? But here, from here to here, is even. That's why the midpoint again is between 2 numbers, correct? And we have another quartile, which is Q3, from here, 25 to 85. So now I'm going to use this data set and explain a box plot. Box plot is a plot that we can draw using 5 numbers. What are those 5 numbers? One is minimum, then Q1, then median, then Q3, and the last one is maximum. These 5 numbers are important. We use these 5 numbers to draw a box plot. I didn't talk about mean, correct? I just talked about median. So we call this 5 number summary. If I ask you what is 5 number summary in this data set, you will write down minimum 51, Q1 55, median, what was median? 61, then Q3, which is 76, and then maximum, which is 79. This is 5 number summary, correct? So now for this data set, 5 number summary is minimum, Q1, median, Q3, maximum. I'm going to use this to draw a box plot. Do you have any question? Any question? No? Why you are quiet today? Okay, so to draw a box plot, we need a y-axis, x-axis. We have y-axis and x-axis here. Sometimes we can show two box plot in same x-y axis. Sometimes just one. Depends on if they have the same data on y-axis. So now this data is all the numbers in our data set. It starts from 5 up to 85. Okay? So I should measure this. I want to measure it like 10, 20, 30, 40, 50, 60, 70, 80, 90. I don't need more than this because the maximum number is 85. Okay? So I started from the minimum to maximum to cover all the data. So here, let's say this is the name of our box plot. Consider a second travel time data set. Okay, travel time data set. Travel time box plot. So I put the name here because maybe I have two of them, and then I can have another box plot here with different name. Okay, I will show you there is another box plot also. So I will start from the minimum number 5. 5 is here, correct? So draw an imaginary line, and then for the minimum, you can have a point, you can have a small line like this. Then I will find the maximum. Maximum is here. Same, a point or a line, same as this one. So for minimum, maximum, we have just a small line or point. And then I'm going to find Q1. Q1 is 15. So I'm going to find Q1, median, Q3, all of them, these 3. So because I'm using 5 numbers, these 5 numbers to draw a box plot. 15 is here. For the Q1, I'm going to draw a line. Okay. For Q3, what is Q3? 42.5. Let's say here. I'm going to again draw a line. So this was minimum, this was Q1, this was Q3, this one maximum. What remained? Median, 22.5. Let's say here, again another line. So now, I'm going to connect these lines like this. What we have here? Box. So this is the box. And then we have to connect this to the box, connect this one also to the box. And this is our box plot. We use 5 number summary to draw a box plot. I will explain what this box plot can do also. Do you have any questions so far? So the first line is Q1, the second line is median, the third line is Q3, correct? And then this one is minimum, this one is max. Do you have any question? Shall I ask you a question? If you don't have any question.
Doesn't matter where we want.
You don't want me to ask any question. I'm just kidding.
No.
Doesn't matter what.
Doesn't matter where we want to make the box. So, is it
You can shift it that side, that side. So wherever you are going to put this, you should write down the name. Because maybe you have another box plot with the same data set. So it says the second travel time. I think there is another box plot using another kind of time, travel time. We'll see. So now my question, look at this box plot and answer my question. What percent of data are between Q1 and Q3?
50%. Oh, 75.
Between Q1 and Q3. Why you changed your answer?
I was thinking minimum, sorry.
No, from Q1 to Q3, what was that? 50%, correct? So from here to here, we have 50% of our observations. Correct? I could say like that. What percent of observation have travel time between 15 and 42.5? You will know 15 is Q1 and then 42.5 is Q3. You will say 50%, correct? Or I could say what percent of observations are between 15 and approximately what percent of observations are from 15 to 43. You would say 43 is close to Q3, correct? Approximately we have 50% of observations because I'm talking about Q1 to Q3, correct? So now what percent of observations are from Q1 to maximum?
75.
Exactly. From here to here, 75%. So now you know what type of question you can see related to this box plot. From Q1 to median, 25%, correct? Median to Q3, 25%. Q3 to maximum, 25%. Here, minimum to Q1, also 25% of observations. Do you have any question? Now, do you remember I said we have shape for quantitative data set, okay? We had shape for histogram, we had shape for a stem and leaf plot. So now let's see how this one works. First of all, we should rotate our graph the way to have minimum observations to maximum observations. Like this axis should rotate like this, correct? 90 should go this side, 0 should go to the right side. So let's see how I can do this. So let's say this is 0, this is 90. So if I rotate that, I have a small portion here, correct? And then I will have smaller portion here. And then I have something like this. Correct? Almost. So now, median is around the peak. And this is the median. Correct? So I can draw a peak around median. What happened? Right skew. Correct? So we can find a shape also using box plot. This is right skew. But always be careful from minimum to the maximum. When you are rotating, you should be so careful. Okay, so now let's see what we have in the second page, and then I should talk about outlier. What is outlier? Come on. Outside of the data set. That is observation that falls outside of overall pattern or far from other observations, correct? So look at this. This is the box plot. This is the one I draw. And then we have another travel time for North Carolina. This was New York. So see, we can separate them. We have same travel time on y-axis, but different data set, different information like Q1, Q3, median. So now this is the one I draw, and this is the other one. So it means you can have two of them. If you want to answer any question, always be careful which one they are asking for. For example, New York, you are asking to find the percentage from here from up to somewhere for New York or North Carolina. And then here, if you have a curve like this, what shape we have? Left scale. And if you have a peak here, you will have symmetry, and then you will have a curve here. So this will be a right scale. Correct? Do you have any questions? So now I want to talk about outlier. How we can detect outlier. Okay. There is something we call that interquartile range. We use third quartile and first quartile to find interquartile range. I, Q, R is quartile 3 minus the first quartile. In our example, the third quartile was 42.5 minus 15. The interquartile range is 27.5. This is the travel time, that's why we have unit of measurement, okay? We use interquartile range to detect a possible outlier. And there are some steps. So we have this formula, and then the next step is multiplying IQR to 1.5. This is a fixed number. This is a fixed formula. 1.5. Okay? So now, this is the first step. The second step, multiply this to 1.5. Okay, calculate this for me. 27.5 multiply 1.5. Calculators. Come on, why you are slow today? Please. Okay. Check it. 40 what? 75. Correct? All of you?
It's 41.25.
41.
25.
Did you calculate with phone? Oh. Yeah, my phone always gives me wrong answer for some reason. Okay. We use this number. Listen to this. This part is difficult. You should understand. So what was the first step? IQR, Q3 minus Q1. I found this number. Multiply this number with a fixed number 1.5. Then you have this number. On box plot, I'm going to start from Q1. Go this much unit. What was that? 41.25 down. Means you're subtracting these two, correct? Subtracting 42.5. Subtracting this from here. No, this one from here. You will go to the negative side, correct?
Yes.
Because this is y-axis. You have negative and we have positive here. So what is the number? Negative what?
26.25.
26.25. And this is our boundary. This is our boundary. This is the last number we can see in our data set, if there is any negative number there.
So from quartile 1, you subtract like the 41.
Yes.
Okay.
From quartile 1, we are going to subtract 41.25. So we found negative 26.25, correct?
So, question. Does it work the same way up?
Yes. So now, from here, we go how many units up? 2.5. This number, the number,
Oh, 40.
sorry,
Yeah, 41.
41.25. 41.25. 41.25. So what was Q3? Did you find what happened?
It's 42.
So I wrote down 42.5 for
Yeah, that's
Q1, which is 15. Okay.
Yeah.
So now 43 was
42.
Q3 was 42.5. So now we are going up how much? 41.25. What is the last number? What is the number you find? 83 point. 83.75. Why I wrote down here? Because I know the maximum is 85, correct? Maximum is going to be outside of this boundary I'm making. So now you could get my point. What is the conclusion? So I made a boundary, correct, using this number. The boundary starts from negative 26.25 up to 83.75. And then there is one observation. That is a, what is it? Outlier. Why? Because it's outside of the boundary, correct? So this is outlier. Maximum number, which was 85, is outlier because it's outside of the boundary. We even don't have any negative number. Okay, so we are good on that side, but our outlier will be on positive side, positive side of y-axis. Okay, so I will review this again. If you are done writing down everything, I will review. Do you have any question before I review what we did? Okay, so I wanted to detect a possible outlier, correct? We know all our observations are organized from minimum to the maximum. We have minimum number, which is 5. We have Q1, which is 15 here. We have Q3, 42.5, and then we have maximum, which is 85, correct? And then we said we use Q3 and Q1 to find IQR, interquartile range. We found a number for interquartile range. Multiply that number to 1.5. This is a fixed formula. You will find 41.25. Use this unit, use this number to make a boundary for your data set. Use this number from Q1, go down, means subtract this number from Q1, correct? Then you will reach negative 26.25. This is your lower boundary. Then we start from Q3, we go up, means add this number 41.25 to Q3. You will have an upper boundary, 83.75. So all your data should fall between this number and this number. This is the overall pattern or range of your data. Correct? If there is any observation falls outside of this overall pattern, that is outlier. And here in this data set, 85 minutes was the only number is falling outside of overall pattern, and that is an outlier. Do you understand this? Is this clear? Yes.
Which is the IQR, the 27.5 or the 41.2?
This one is IQR.
Okay.
And after we found IQR, next step is multiplying IQR to 1.5, which is a fixed number. This is IQR. 27.5. The difference between Q3 and Q1.
So how would you explain the bottom one? So
This one is just a fixed formula. Just a fixed formula we always use to say approximately this much, data will, approximately our boundary will be between these two. So this is just kind of measure.
So the bottom number is just finding the boundary, maximum.
Yes. Finding the boundary. 1.5 multiply IQR gives you a boundary. And then you should this unit to figure out your exact boundary, correct? Any other question? Question? Sure? Is that clear? Are you sure?
Yes.
Everyone? Okay, so now we are done with quartiles, spotting outliers. And look at this, the 1.5 multiply IQR rule for outlier. This is the second step. Now we want to talk about another measure of variability, a standard deviation. We show standard deviation with S. In your note or anywhere you have, write down S power 2 means S squared is variance. Variance. This is variance. VAR. So S squared is variance. S alone is standard deviation. So what's the relation? S square variance. S is a standard deviation, means a square root of variance is standard deviation, correct? The square root of variance is standard deviation. This is just a math. You should know if you take a square root of this, you will have S, which is standard deviation. Okay, so now you should know the difference between variance and standard deviation. But in this class, we are going to just talk about the standard deviation. Okay, but you should know the difference. So, a standard deviation has a formula. You already know what summation means, correct? We talked about that. Means add them up. So now what you're adding? This parenthesis square. For the first observation, we will have x1 minus x bar squared. For the second observation, we will have x2 minus x bar power 2. Then next observation. The index of x will change from 1 to n. What was x bar? X bar is mean, correct? Means each observation minus the mean. So to be able to find the standard deviation, you should have the mean, correct? You should have the mean. So now let me write down. You maximize this. It will be more clear. Is this better? So do you see that? The first observation minus their mean, power 2, minus. The second observation minus mean, power 2. And up to the last observation. So if we have 14 observations in our data set, how many parentheses we should have? 14 parentheses, correct? Subtract each of individual observation from their mean. And then here on denominator we have n minus 1. For mean we had just n, correct? Here we have n minus 1. Means if we have 14 observation, the denominator is 13, correct? And then because this one is variance and we want a standard deviation, we are using a square root, correct? So square root of both sides, this side and this side. A square root of this side gives us a square root of all this formula, correct? A square root of this side gives me S alone, which is a standard deviation. So this is the formula for standard deviation. Okay? So now, let's solve. This one. Because we found the mean for this one, huh? We found the mean for this data set. Okay, so let's use the formula and find the standard deviation for this example. Okay, so the first step is to find x bar, mean, correct? What was x bar for this question? 61 was median, huh?
63.5.
63.5. This is the mean. Is this correct?
Yes.
Yes. So now I'm going to use the formula S equal to on the denominator. How many observations we had here? 14, right?
Yes.
So on denominator we have 14 minus 1. The first parenthesis is x1 minus mean. x1 is 51, the first observation, minus 63.5 power 2. Correct? Do you understand what I'm doing? This is the first observation. x1. This is x bar. Plus second observation 76 minus 63.5 power 2 plus 57 minus 63.5 power 2 plus 55 minus 63.5 power 2 plus 64 minus 63.5 power 2 plus. Am I right?
Yes.
54 minus 63.5 power 2 plus 6. Why I have 6 of them? 51, 76,
You forgot
57.
63.
See, I was not right.
Yeah.
Why you didn't find that? 63.5. Oh my god, I chose the wrong example, huh? I know. 58 minus 60. 3.5 power 2, and then we will give up. That's it. Okay. I have to continue. 65 minus 6.
I'll let you do it.
No way. I have you for this reason. I told you bring your calculator just for this. 65 minus 60, and then I have 4 more. I'm continuing here, okay? 77 minus 63.5 power 2 plus 59 minus 63.5 power 2 plus 78 minus 63.5 power 2 plus 53 minus 63.5 power 2. I have 14 of them.
This is French paper.
Keep this. I have 3.5 here. Then I have 9. 12.5 power 2. Oh. Calculate this to see if I'm right or I'm right. So, actually we have negative sign, huh? For the first one.
Yeah.
And then for the second one, we have 6 plus 8.5. 14.5. Right?
12.5.
The next one?
Yeah, it's still 12.5.
12.5. And then next one. Okay, you calculate that
Negative
one.
6.5.
6.5?
Negative.
Negative 6.5 power 2 plus negative 8.5 power 2 plus no, it's exactly yeah. That's this is 0.5 power 2. What about negative sign? Don't forget that. No? Okay, next one. Don't embarrass me, just say
1.5.
plus what?
1.5.
1 point
5.
power 2 plus this one is negative for sure. Right? 63 minus 63.5, and then 58 minus 63.5 is
Negative 5.5.
negative 5.5 power 2 plus
15.5.
15.5 power 2 plus 2 point
2.5 squared.
1.5
2.
2.5
Yeah.
power 2 plus, and now we are in this one.
13.5.
13.5 power 2 plus
Negative 4.5.
power 2 plus
14.5.
last one.
Negative 8.5.
10.5?
8.
8.5.
Is it?
53 minus 63.5.
Yeah,
it's
it's
9 point something. Huh?
Negative 10.5.
This one is 1.5. Yeah, I said something.
The last one is negative 10.5.
This should be 1.
Yeah. Negative. It's 53, right?
53
Yeah.
minus
Yeah, it's
63.5.
negative 10.5.
10.5.
Yes.
So 65 minus 63.5 was 1.5, correct?
Yeah. Yeah, 1.5.
and then divide by 13. Okay, so we will give up here. The rest is yours. So one thing about a standard deviation. So actually we can continue. We have time. Yeah, we have time. So one thing, I will just explain this. I will have another easier example to find mean and standard deviation. But this is for, kind of long calculation. Maybe in your homework you have such a thing. Okay, so one thing here. All these parentheses you see here, if you square them, there is a negative sign, correct? What happens? Becomes positive. Don't forget, I have many students who forget this. Be careful. Negative sign power 2 is always positive. Then, whatever negative you have here becomes positive, correct? Yes. So what happens? Everything on numerator is positive, correct? Denominator is also positive. Always. You don't have negative number of individual. So the aim is this. Point is this. A standard deviation is always greater than or equal to 0. Means always positive number. If you find a standard deviation and your number is negative, you did something wrong in calculation. And then always at the end, have a square root. Find a square root of whatever under this. So now the easy example.
Yeah.
Huh?
Can't you just take off all
No,
the squares?
this is yours. You are my student. You are responsible to solve all these difficult questions. That's not my responsibility.
So like, I just got a question. You know how you said square all of them and then square root them?
Yes.
So like,
take off the
what if
square?
the square?
No, you cannot because this is a fraction, correct?
Oh, okay.
And then these are all adding together. So if you wanted to do that, you should separate them to how many? 14 fractions, and then square each of these fractions, and then at the end you will see you have a square root of 13 for each of those fractions. So it doesn't work like that. You
Okay.
remove those the square and
So
then
we square all of them, add them all together, divide it, and then we find the best root. Okay.
yes. So let's solve an easy example now. Find the mean and standard deviation for this one. The number of serving of fruit per day consumed by 5 adolescent female is recorded to be 2, 1, 3, 0, and 4. Find the mean and a standard deviation for this data set. What is the unit of measurement here?
Serving.
Serving fruit, number of fruit per day, correct?
Yeah.
So don't forget to put that unit of measurement after your mean, after the standard deviation. Use the standard deviation formula to find. But first we should find the mean, correct? observations you have?
5.
You have 5 also.
What is n again?
N is the number of observations. So you have 5 information, correct? Solve everything on your own. Don't look at the board.
Do we want specific like decimals or just want to get a square root?
I got 1.15.
Oh, you're right. On paper. But I just typed it. Yeah, you have to type it in. Oh, no, I just did it on paper because I put it on my laptop. And then I did it right after.
This should be easy, huh?
Yeah.
Yes.
Okay.
Oh,
Finish it.
Millennial professors. Yeah. Dig around right after class. Right after class.
And continue
I don't
to
know.
the final answers.
Zero power 2 is?
0.
0.
Yeah. 2.
No, I want to go step by step because there are some students who didn't see this kind of math for a long time.
Okay. 0 plus 1 plus 1 plus 4 plus 4. 8, 9, 10, 12.
Correct?
Yes.
Square root of 5. What is the square root of 5?
5 times. 5 over 2.
5 over 2.
5 over 2.
Yeah, 5 over 2.
They simplified it and then
Oh, you just
yeah,
simplified
then we
it.
just calculated
Okay,
it
so 2.5,
as 1.58.
1.50,
58
okay.
servings per
Serving fruit
per day.
per day. This one also. 2. Serving fruits per day. Do you understand these?
Yes.
Sure?
Perfect. Yeah.
So now, what we learned today? Today we learned about measure of variability, quartiles, correct? There is one important thing I have to mention and talk about. I'm just reviewing everything, then I will reach that point. So last time we talked about measures of center, correct? Mean and median. We said mean is average of individuals. Median is the midpoint, correct? Then today we talked about measures of variability, standard deviation and quartiles. Quartiles were first quartile, third quartile, and then these both are the midpoint, correct? Q1 is the midpoint to the data set on the left side of median, correct? And then Q3 is the midpoint for the data set on the right side of median, correct? Then we said Q quartiles always divide the data set to 4 exact parts. 25%, 25%, 25%, 25%. Median divides the data set to 2 exact parts, which is 50%, 50%, correct? These informations are important. And then we talked about standard deviation, measure of variability. And this is a formula, we find the standard deviation. Later in chapter 3, you will understand how we are using mean, how we are using the standard deviation. So now, if you remember last time I talked about resistance measure. Do you remember?
Yes.
I said there is this mean and median. I compared these two. I introduced an outlier to a data set. That outlier changed the mean a lot, correct? But it didn't have that much effect on median. So that's why we said median is not resistant to the outlier, correct? Right? Well,
It's resistant.
Yeah.
resistant.
Yeah.
Median is resistant because it doesn't change that much. So now you are paying attention. So median doesn't change that much. So median is resistant to the outlier. And then it was a midpoint. Just change this much, this much. That's it. That's why. For mean changes a lot because it's a summation. All of a sudden you are adding a huge thing. So now my question, if I want to compare quartiles and standard deviations,
Quartiles.
what? Quartiles what? Are resistant to the outlier. Why?
It doesn't change drastically when there's the outlier.
Why? There should be
You're
some.
using the median instead of the mean.
Exactly. So what she said? She said it's acting like a median, correct? Because it's a midpoint. And still, quartiles are midpoint, correct? So because quartiles are still midpoint, they don't change that much to the effect of outlier. So I'm going to write this down. Quartiles are resistant to the outlier. Quartiles are resistant to the outlier because they are acting like median, correct? They are midpoint. correct? So what about the standard deviation? Standard deviation is not resistant because as you see it's a kind of summation again, correct? You're adding in another number, another huge number. It's not resistant to the outlier. So you can even, because we talked about measure of, resistant or non-resistant, you can even complete this and say standard deviation is not resistant because it changes a lot, because it's a summation. You can add all the information you know. And then here, because it's midpoint and it doesn't get affected by the outlier. Do you have any question? So let me see if I talked about everything. A standard deviation is always a positive number. Keep in mind because we are going to use this information later. A standard deviation is always a positive number. Okay? Any question?
No.
I need question. Otherwise I will ask you a question. We will have a pop quiz now, right now. I'm that kind of person. All of a sudden, you know.
So there's only a first and a third quartile, right?
Oh, that was your question. He doesn't want pop quiz. What is that?
There's only a first and a third quartile, right?
What was the second quartile? Median, midpoint. Another name for quartiles. I guess
So we just used the squared, because you know how you said the standard deviation, and then there was what was the one that was squared?
Variance. Variance.
Variance?
So variance is S squared, and then S is standard deviation, and then a standard deviation is the square root of variance. Do you have any question?
No.
Yes.
Oh, yes, she does.
Why is a box not the shape of the box?
I don't know why it's shape of the box because
You gotta say why not.
probably the person who invented that, like box, like boxes, probably. I didn't think about that. That was a difficult question.
Maybe because of the quartiles. Because there are 4 sides.
Oh yeah, that makes more sense. Then it splits them off into quartiles.
Because of splitting that, then yeah, you're right.
So if you're really looking at a data set of like real data, what would you use standard deviation for?
Next chapter, I'm going to show you how we are using a standard deviation and mean. You will see that. To find a probability, we need to know standard deviation on our population, and then later we will talk about sample, and all of this makes sense for you, why we are using it.
Oh, my car.
Always positive. Always the standard deviation is positive.
Really? What if it's a trick question and it's like the outcome is negative?
No,
There's something
it doesn't happen at all. No.
So you're not making trick
No,
questions?
because you know everything under square root should be positive, correct?
Mhm.
This is the reason, mathematical reason.
Okay.
Always under square root, everything should be positive. Unless we have imaginary number and those kind of things, okay? Okay, so we are done with chapter 2. Finish your assignment. Assignment is February 11th. See, you have long time. And then we had enough examples for this thing. We'll see you next week. Have a good weekend.